All right, so in this lesson, we are going to identify and represent slope. Then we're going to show evidence that we have identified it successfully. So before we start talking about slope or constant rate of change, and actually in this lesson, I'm going to refer to it as constant rate of change. So before we start talking about constant rate of change, I should show you a few examples. So if you look here, we have grapes in pounds, or the weight of grapes in pounds, and the price. Now, the price is increasing by $1, $1, $1, $1. Every time that the price increases by $1 is because the weight increases by 2 pounds, by 2 pounds, 2 pounds, 2 pounds. So every time this increases by 2 pounds, this one increases by $1. Let's look at this next example. So we have time measured in minutes, temperature measured in degrees Fahrenheit. So the temperature goes from 90 to 95, 80, 75, 70. If you notice, it decreases by 5 degrees, 5 degrees, 5 degrees, 5 degrees. And this is plus 2 minutes, plus 2 minutes, plus 2 minutes, plus 2 minutes. So the temperature decreases by 5 degrees every 2 minutes. Constant rate of change. It's constantly changing like the same way. And then lastly, we have this horizontal one table. And we have a cost and we have number of tickets. The cost is increasing by $5 when the number of tickets is increasing by 4. So $5 every 4 tickets. Constantly the same. Now, let's look at this. So on all of these, I want you to put the triangle Y, which means change in Y, and triangle X, change in X. So we can see that the Y is increasing by 2. It increases by 2, and it increases by 2. Every time the X increases by 5. Increase by 5. Increase by 5. So change in Y over change in X. So we're adding 2. And when we add 5, so we add 2 to Y when we add 5 to X. And a positive over positive is a positive. So if we look here though, if you can see, we jump to 11. So it's actually an increase in 4. And this one increases by 10. And then it increases not 2 again, not 4 again, but by 6. And this one would increases by 15. So let's take a look at this. First, actually, before we continue, I want to show you how this works. We just skip some numbers like 0, 5, 10, 15, 20, 25, 30, 35, 40. So 1, 3, 5, 7, 9, 11, 13, 15. If you can tell that these weren't written, obviously, these blue ones, but that's okay. You don't have to show everything. So let's go back to orange. Now we're looking at this. So it's plus 4 plus 10. So positive over positive is a positive. 4 over 10. And positive over positive is a 6 over 10. You could show that they are proportional or the same, like, or they're equivalent by showing equal fractions like this. But sometimes it's difficult if you don't know what you're multiplying by. So instead of doing that, I'm going to have you divide. 2 divided by 5 is 0.4. 4 divided by 10 is 0.4, 0 and 4 tenths. 6 divided by, that's not 10. So I'm going to get rid of that. That should be 6 over 15. So 6 over 15 is also 0.4. So if you notice, all these fractions are equivalent to 0.4, 0 and 4 tenths. So let's talk about this initial nice smallest version, most reduced version. So the change in Y. So the Y increases by 2 when X increases by 5. So this is a constant rate of change. It constantly does the same thing, even when it looks different. When it goes instead of 2, 5, 2, 5, 2, 5, if it goes 4 and 10, 6 and 15, it's still constantly the same. It's just a different like version of itself. So it's all, we can show that by doing 0.4, 0.4, 0.4. Now usually you won't see like this empty space here. You will just see it like this. So in this case, just to show you, we would write +2, +2, and you're like, I'm good, it seems good so far, it seems good. And then you're like, bam, +4, bam, +6. That's okay. It's just skipping some in between values. Or it can be okay, as long as it makes sense over here. So +5, +5, +5. This one's +10. And this one was +15. So we can remember this one I left space for the blue, and this second one I did not. They are the same. So I'm going to end up with the same values, but it's going to look like this. I'm not going to leave spaces. So change in y over change in x. I would write the first one. So a positive over positive is a positive. And then I would look for the next one, a positive over a positive is a positive. And a positive over positive is a positive. My goal is to show that these are either all the same or all different. I'm not going to show the arrows because most of you won't on the work. So 2 divided by 5 is 0.4. I'm going to just turn it into its unit rate, 0.4. And I did it again. Let me make that correction. I don't know why I keep saying 6 over 10. Or writing 6 over 10, 6 over 15. So 2 over 5 is 0.4, 4 over 10 is 0.4, and 6 over 15 is 0.4. So these are all secretly 0.4. So it's constantly the same. So, and then I just showed you all the explanation. Well, let's do it again. So the y, and we're going to concentrate on this simplified version. The y increases by 2 when x increases by 5. Cool, let's go to the second page. So we have time and altitude. So this is going to be the change in altitude, and this will be the change in time. So the altitude, let me write that. The altitude is decreasing by 5. So we're good. Look, it's like always like by 5, decrease by 5. And it's like, oh, that's weird. It's decreasing by 10 and decreasing by 20. Does that mean it's wrong? No. Does that mean, does it mean it's not constant rate of change? No, it could still be constant rate of change. I just need to check this side. +3, +3, +3. That's a good sign because the 5s and the 3s go together. +6, +12. So this is going to look a little different. So let's check it. So change in altitude over the change in time. So a negative over a positive is a -5/3. Let's see if that equals a negative over positive, a -10/6. And let's see if that's the same as negative over positive is a -20/12. So the easiest way I can see it like times 2, but most of you will write it in decimal form. So -1.66 repeating. 10 divided by 6, -10 divided by 6 is -1.66 repeating. -20/12 is -1.66 repeating. And constant rate of change, -1.66. Well, let's talk about this simplified version. So the altitude decreases, remember decreases, by 5 feet when the time increases by 3 seconds. Cool. And our last one. So we have time and temperature. So this would be, I guess, change in Fahrenheit, because the temperature, that there's two T's, and this can be like the change in minutes, I guess. So this is minus 3, minus 3, minus 6, minus 12. So not necessarily bad. They're all multiples of 3, so it seems like it might be good. It might work out easily, or we can tell if it does. So negative 4 to 0. So negative 4, go to the right 4, so plus 4, and then plus 4. Looking good because these are the same. This is plus 8, and this is plus 18. Yeah. So I'm going to check this. So change in, oh, remember the one that we care about goes on top. So change in Fahrenheit over change in. Make sure that this one's it has to go on top, even though it's like in reverse. It's like these ones up here where the dependent variable's on the right. So it's second, but it goes on top first. This one's second, the temperature, but it goes on top. Okay. So this is a negative over a positive, which is a negative 3 over 4. Same thing. So negative over positive is a negative 6 over 8. And a negative over positive is a negative 12 over 18. Now, this doesn't look too bad, but 4 to 8 is easy. 8 to 18 or 4 to 18, that's difficult. So decimal form is really going to help me here. So negative 3 over 4 is negative 0.75. Negative 6 over 8 is negative 0.75. And negative 12 over 18 actually gives me negative 0.66 repeating. So these are not the same. So I want you to put an X on, the obvious ones, or one or ones that don't work. Like the obvious difference, just show that you know. So this is just not conservator change. And that is it. Thank you.